name is Paola Maio. I'm an EU project officer at the European Heat Pump Association. And today I'm happy to be your host for the next 2 hours. So quick overview of the agenda. We will have a short presentation of the PUSH2HEAT and the SPIRIT projects, along with an overview of the findings of a PUSH2HEAT survey that we conducted to identify barriers and opportunities for heat pump deployment across Europe. And then it will be the turn of people saying that they not see the presentation.
We have actually had the same.
Okay.
Okay. So I think it's a problem of Zoran. Maybe you can try to disconnect and reconnect to the meeting again. Thanks.
Okay, so let's move on to the agenda. There will be Josephine Besseler for the HPA that will present the EU policy and regulatory landscape on industrial heat pumps. And then it will be the turn of Cording Arpagaus from OST, who will present perspectives on the technical and economic factors of industrial heat pump through the PESTLE lens. We will shift more to the academic side with Milan Perez-Kaman from Cardiff, who will present reflection from the field on the future of heat upgrade technologies. And then we will have a perspective more from the industry itself with Tor Hodne from ESPH that will present the ESPH journey through market barriers and breakthroughs. And we will end up the presentation with Bart Eyerts from the Tiense Sukker Raffinaderei that will give us insight from an industrial heat pump end user. We will close up the session with, of course, the panel discussion and the Q&A moderated by Josephine Besseler, and we will close up the event at 12. Before starting, just a few housekeeping rules. So if you happen to have a question during the webinar, no problem, you can write it in the chat. What I suggest is to add the name of the speaker you are referring to, so that if the speaker can answer straight away in the chat, or we can address the question later on during the panel discussion. If you have to also leave earlier, don't worry. The webinar will be recorded and will be available on the HPA website as well as our project website. And everything that is discussed today will be available soon, along with all the presentations. So we can start with a few words on the PUSH2HEAT project. PUSH2HEAT is a project funded by the Horizon Europe program. It kicked off in 2022. It has 19 partners from 6 EU countries coordinated by Tecnalia. PUSH2HEAT has currently 3 demo sites, one in Westenborg in the paper industry, another one in Guarcino, Italy, in the paper, also in the paper industry, and the third one in Antwerp in the chemical industry. Its overall scope is to address the technical, economic, and regulatory barriers that prevent heat upgrading technologies to be widely deployed, and also to demonstrate tailored business models for higher market penetration of these technologies. Moving forward, project that stands for Implementation of Sustainable Heat Upgrade Technologies for Industry. SPIRIT is actually a sister project of PUSH2HEAT. Indeed, its aim is to enable industrial heat pumps to become the reference climate neutral technology for covering heat demand for temperatures up to 160 degrees by 2030. It has 70 partners from 8 EU countries and also 3 demonstration sites in the food and the paper industry. So, of course, if you want to know more about this project, you can scan the QR code, follow our LinkedIn page in order to be updated and to be the first one who can share and can see the results of these 2 projects about industrial heat pumps. So we can start with a presentation on the findings that we have found through a survey that we conducted within the PUSH2HEAT project. Indeed, this roundtable, it will be really useful to see the key findings of the survey. That identified the barriers and the drivers for the deployment of heat upgrading technologies across Europe. In these surveys, we reached out to 4 key groups of stakeholders: research, university, and policy organization, industries with heat upgrade technologies integrated, industries without heat upgraded technologies integrated, and of course, heat pump manufacturers. We then analyzed the result using a PESTLE framework, meaning it allows us actually to structure our findings into 6 categories: political, economic, social, technical, and environmental. And here you can actually see the result of this finding divided into these 6 groups. Well, starting off with the political point of view, of course, one of the most highlighted barriers was the fragmented policies across the EU related to these technologies, as well as a limited visibility of heat upgrading technologies in national decarbonization strategies, and also unclear guidelines on excess heat recovery at EU and national levels. Moving forward on an economic point of view, of course, the most pinpointed finding was the high initial investment cost for industries to uptake these technologies, followed by a limited access to finances and complex subsidy application processes. Another thing that was highlighted in the survey, always on the economic side, was also the lack of tailored business model for these technologies to implement in the most suitable way into industries. And that's what we are actually trying to do with PUSH2HEAT. Moving forward from a social point of view, of course, one of the most highlighted barrier was the low awareness of these technology benefits, as well as a cultural resistance from industries to uptake these new technologies and to make the switch to this kind of technologies. What was also highlighted was a limited industry collaboration and knowledge sharing. So that's why with this project, one of the outcomes is also to share the best practice and the results in order for everyone, that everyone can use them to uptake these technologies. From a technical point of view, one of the most highlighted barriers was the skilled labor shortage, along with an adequate vendor or supply chain support. Also was highlighting an incompatibility with existing system, as well as a lack of appropriate infrastructure. And that leads to the other point, which is the legal side. The legal side, actually, one of the most controversial barriers or topic that it's around the heat pump world, it's the restriction on refrigerant and specific energy carriers that lead us also to an unclear guidelines on excess heat recovery at EU and national level. We can close the barrier session with the environmental aspect. To mention what I just said, of course, one of the biggest concerns on the environmental side are the concerns on the impact of this refrigerant. So this wraps up the barriers for heat pump adoption in Europe. Of course, we can move on the positive side, because we also found out there are lots of recommendations and opportunities that can help us to overcome these barriers. So let's see some of them. For example, from a political point of view, of course, there is a need of government incentives, as well as tax reduction for electrification and a more accessible way to have EU funding. What was also highlighted is there is the need of a stronger regulatory mandates and cross-border policy harmonization, and especially from a strategic public-private partnership to support the deployment of these technologies. From an economic point of view, of course, there is the need of development of innovative financing models, as like partnership with energy service companies, and incentives, of course, helping early adopters. From a social point of view, what was highlighted in the survey is the need of a collaboration with research institutes that could play a crucial role in advancing innovation and market readiness, as well as targeted education and outreach program to raise awareness among industries, policymakers, and the public. And that's what actually we do here at EHPA. From a technical point of view, something that I wanted to highlight was this data that was coming from the answer of heat pump end user. Here you can see that 83% of them report a wasted generation of over 1,000 megawatt hour per year, highlighting this as a huge opportunity and a huge potential for energy recovery. Moving forward from the legal side, of course, there is a need of regulatory alignment that could ease the market access and reduce compliance burden. And of course, on the environment, a lot of advantages, of course, an overall contribution to the national and EU sustainability goals. And also the opportunity of using natural refrigerant was also highlighted in the survey. So, and that wraps up the barriers and the driver that we found out through the survey according to the respondent for the heat upgrade technology deployment in Europe. But before moving forward to the next speaker, I would take this opportunity to maybe know each other better. What we can do is to launch a poll to tell us what do you come from in terms of your organization. You can see right now a poll in your screen. I don't know if you see them yet. Okay, so you should be seeing a question, which is which of the following group does your organization most example? So to see if you can be also grouped in the stakeholder that we reach out to through the survey. You can tell us if you are a representative of an industries with heat upgrade technologies integrated or not, or if you are a representative of a research university or a policy organization, as well as an association, NGO, or consultancies. So I'm gonna vote myself too. So we can already see some results. Okay, so for now there is a majority of heat pump manufacturers, which is, someone is also writing in the chat, consultancies. Well, a majority of heat pump manufacturer, that could be a great way also for you to give us a feedback and your perspective on what we are going to present and all the topics that are going to be raised during the discussion. Let's wait a little bit more. Still, the heat pump manufacturers lead this ranking. Okay. Thank you all for your response. We have a more clear idea of who is listening to us today. And we can move on now to our first speaker. Please let me introduce you to Josephine van Besseler. Josephine worked for 4 years at the Organization for Sustainable Energy, the Flemish Heat Pump Association, which also is a member of EHPA. She has a master from the College of Europe in Bruges, where she studied European Political and Administrative Studies. She also has a master in International Relations and Diplomacy, and today Josephine manages EHPA's policy team in the role of Policy Director. So Josephine, whenever you're ready, the floor is yours.
Thank you.
Okay. Okay. Is this? Yeah, we are in the same room. So, okay, but good, we avoided the echo. Great. So I take control over the slides. Very good. Thank you very much, Paula, for the introduction. let's start indeed. I will present to you the policy and regulatory landscape for heat pumps, but first a short introduction. I think most of you know HPA, so I won't spend too much time on that. So we represent the whole value chain, so not only the heat pump and component manufacturers, as I have seen there's many in today's webinar, which is great, but we also have the national heat pump associations, utilities and consultancies, and research institutes and universities among our members, which are around 230 at the moment. So we focus as EHPA not only on residential heat pumps, but also increasingly on industrial and commercial heat pumps. And we have a specific industrial and commercial heat pump working group. And here you see the members of that group. So as you see, it's not only the manufacturers, but it's also utilities, consultancies, and research institutes. So we have a call, I would say, once every 2-3 months. It depends. The next one is next week. So if you are a member of EHPA and interested in these heat pumps and not yet involved in those calls, yeah, let us know and we will gladly add you to these so you can get an update on the latest policy developments, but also the collaboration with end users. And there we collaborate very closely also with the colleagues from the projects team. So one thing that we have been working also in the last months is really the focus on policy recommendations for industrial heat pumps, because there's a lot more requests for that and a lot more attention towards in decarbonization of industry. And these are the 5 main topics we have come up with. Of course, there's a much lengthier paper which you can find on our website, but this is really the summary in short, and it reflects, I think, very much with what Paula has shown in the slides before as the result of the PESTLE analysis. So both the barriers and the recommendations we identified are very similar. Of course, this is really a very short summary, but it's really the economics that always come back. So both CapEx and OpEx that we have to work on. The electricity to gas price ratio is both for industrial and residential heat pumps a key issue. We need to make sure that electricity bills go down, that taxes and levies on the electricity bill are not that much higher than a gas bill, so that there's more of a level playing field. Also, help with the CapEx is very important. Then on regulation, indeed, we need much clearer, long-term, stable policies for industrial heat pumps, and also very clear, for example, that it's required to electrify your industrial process when you do a permit or a license for a new or renovated industry. This type of, more specific regulatory instructions, so to say. Then on the energy system, we also hear very often that, okay, once an industry has decided to electrify, that then there's often issues with grid access. So this is really important that when you electrify, you have a priority to an upgraded grid access, and that also in general grid investments are encouraged. But that also the flexibility that these heat pumps can offer is better taken into account and remunerated. And of course, the knowledge, that's something that Paula also very clearly mentioned, raising awareness, not only with end users and with the people in the factories, but also in general, also with policymakers and so on. And then the topic of waste heat recovery, or excess heat, as it was called in the PESTLE analysis, is very important on that one as well. There's not enough awareness and not enough this notion of, okay, this waste heat is not wasted but can be used again as a source. And also in legislation we should mandate it much more clearly that whenever you have waste heat from a process, that you should come up with a plan to reuse it again, so we minimize that it's just dissipated. So this is very short what we have come up with, and as I said, it reflected very much what was mentioned in the PESTLE analysis. What I will go into now is give you a bit of an overview on what is currently going on at policy level, at EU level, on policies that are working on industrial decarbonization. So in February, the European Commission published the Clean Industrial Deal, and that outlines concrete actions to turn decarbonization into a driver of growth for European industries. It's in 2 ways. So on the one hand, this Clean Industrial Deal really wants to focus on decarbonizing energy-intensive industries, and on the other hand, it also wants to push for a further manufacturing or competitiveness of the clean tech sector in Europe. And you see for our sector, for the heat pump sector, both are very relevant because heat pumps are important to decarbonize, electrify energy-intensive industries up to 200 degrees mainly. And on the other hand, it's also very important that we boost the manufacturing of the clean tech sector, of the heat pump sector in Europe. So for us, really both angles of this Clean Industrial Deal are really the focus and the key of our work at HPA and of our sector in general. So here you can see a bit more in detail the different business drivers that are included in the Clean Industrial Deal, really also from a high level. Again, there's a very detailed document on this, but just to show you what it focuses on, it looks at making energy more affordable by reducing the electricity bills. It looks at boosting demand for clean products with a range of upcoming legislative initiatives. It also wants to further finance the clean transition. It will look at circularity. For example, for heat pumps, it's very much eco-design related. Then also, of course, even though we want to further boost clean products made in EU, we also have to have strong international partnerships. We have a global market. Of course, we are for certain components reliant on third countries. And yeah, it's important also to keep it, this global trade in a good way. And then skills and quality jobs, of course, that's needed as well to install and to engineer these machines. So one aspect is this affordability, and for that the Commission came up with an Affordable Energy Action Plan, which really looks at this first aspect, this economic aspect. That's a point that we have been advocating for years, actually, this electricity to gas price ratio, because it's so important for the business case of heat pumps. And this has been really taken up by the European Commission in this Affordable Energy Action Plan. So they will really come up with guidance for member states on how to make the electricity bills more affordable. They will come up with guidance on how to make more fair networks charges, on how to switch levies and taxes from the electricity bill to the general budget or other bills. They will look at best practices. Of course, at EU level, there's not a lot that can be done on this because this is often, this can only be decided at member states. So at EU level, you have the Energy Taxation Directive, but for that you need unanimity at the Council, which means that you need to have all the member states agreeing, which is very difficult, especially in these times. So for that, the Commission can give guidance to member states, but then it's really up to the member states to implement these things. So yeah, and the other, mainly the red boxes are other things that are of very much importance for our sector. Then in this Affordable Energy Action Plan, there's also very explicit mentioning of heat pumps and also industrial heat pumps. So it's mentioned that enhancing heating and cooling efficiency by scaling up heat recovery, reuse and heat pump deployments, expanding waste heat recovery in industrial processes and energy services can improve system efficiency and cut costs. So this is very important. It's really, to my knowledge, really the first time that waste heat recovery in industrial processes is explicitly mentioned in a Commission document. So this is really very important. The message has come across. Then also wider heat pump adoption and better home efficiency could reduce fossil fuel import spending by 60 billion by 2030. Also, this message is very important, especially in the whole debate currently about energy security, about reducing our reliance on fossil fuel imports from countries such as Russia. So this is really a very important milestone, I would say. But of course, it's not only about announcing these things and about mentioning them in documents, it's about actual implementation and concrete actions. And here I will present already two of those. So the Commission is, first of all, currently working on designing an innovation fund auction for industrial process heat decarbonization. It's a whole mouthful, but it's very important because it's an auction to subsidize industrial process heat decarbonization, and very concretely with electrification or direct renewables. So it's really focused on industrial heat pumps or other electrification technologies, as well as, for example, geothermal or solar thermal. Other solutions such as biomass, biogas, hydrogen, and so on are in another bucket of the innovation fund. So it's really specific for this. So very important for our sector. Currently, the Commission is still designing this auction and is also asking for input for the auction design. We have submitted our input. The deadline was last week, but we are still also working on a more detailed position paper. So if you have any suggestions for that, you're also very welcome to send them and also to join our call to discuss this next week. So, but the broad outlines are already quite clear. It's really for companies that switch to electrified or direct renewable industrial process heat. The auction will be, they will auction a fixed premium subsidies in either euros per megajoule of electrified or direct renewable process heat or euros per ton of CO2 abated. So you see for many of the aspects, there's still options. So they are still looking at what will be the design exactly. So the bid will consist of, again, a price in euros per megajoule or a price in euros per ton of CO2 avoided. And then, the payments will be structured from entry into operation onwards. But the years, whether you will receive the whole payments in, for example, in 3 years or in 10 years, that's still to be decided. So these things are still in discussion. And you can price into the bid not only CapEx, but also OpEx, and also, for example, other costs for electricity storage or flexibility. So the terms and conditions of this auction will be fixed by August, September, and then very fast, already in December, the auction will launch. So I think this is also an excellent opportunity for all of you. So you're now aware of this. I know there's mainly manufacturers of industrial heat pumps, but please give this message also to all of your clients that this will come up and that they can already start thinking, okay, which projects do we want to submit into this auction? There's a lot more information also that you can find on the website of the European Commission. Maybe I can put the link after my presentation also in the chat. It's really an excellent opportunity for our sector. So yeah, very good to create more awareness about this. Then next to that, we also have currently discussions on the Clean Industrial Deal State Aid Framework. So what is that? That's another initiative. It's so state aid in general occurs when a public authority, so a national, regional, or local government, gives financial support to businesses in a way that could distort competition or trade between member states. And these guidelines, it's not a legal document, but it gives really guidance to member states on how to implement these EU rules. And it should accelerate investments into a number of areas, which you can see below. So it should incentivize rollout of renewable energy, industrial decarbonization, manufacturing of clean tech, and also third-party investments. There was a draft guideline, and the final one should be published very soon in June. But what we have seen in the draft one already, so I will only focus on the industrial decarbonization aspect because, of course, this is very relevant today. We see it's maybe a bit small, but the important part is there that the guideline says that in the state aid should be included aid for investments contributing significantly to reductions of greenhouse gas emissions or improving energy efficiency of industrial activities. And then the point below is very specific, very relevant for us, is that investments aiming at the decarbonization of industrial heat will prioritize renewable heat, flexible direct electrification, and the reuse of waste heat, in particular below 400 degrees. So again, this is very important, direct mentioning of our sector of industrial heat pumps. You really see that there's a lot more traction at EU level in this mandate on decarbonizing industry. And here a timeline of what is still to come. So what is particularly relevant is that by the end of 2025, the Commission will come up with an Industrial Decarbonization Accelerator Act, again, another opportunity really to strongly focus on industrial decarbonization. Then there will be a European grids package, also relevant for these the connections. And then in heating and cooling strategy and an electrification action plan. Again, those we are working hard on our position on those two as well, to have also heat pumps and specifically also industrial heat pumps having a key place in these documents and clearly supported. So I think I took quite a lot of time, so I will stop here and happy also to answer questions. Thank you.
Thank you, Josephine, for your presentation. We can move on to our next speaker. Please let me introduce to all of you Kordin Garpagaus. He is a process engineer with a doctorate from ETH Zurich, and since April 2015, he has been working as a senior researcher engineer at the Institute for Energy System. And he's also author of different publication, more than 100 actually publication about industrial heat pumps, and on a book of industrial heat pump. He's now a senior research engineer at the Eastern Switzerland University of Applied Science. So Kordin, whenever you want, whenever you're ready, the floor is yours.
Thank you, Paola. I hope you can hear me, and I'm not sure what is presented. I have now control, I think, on the slides. I don't know. I try. Ah, yeah. Okay, it works. Yeah, great. So I want to talk about the PESTLE analysis, which is a macro factor analysis, and especially on two factors, the technical and the economic factors. Because I'm a researcher at the university, and this is my major field of competence. So the technical factors. We have done this PESTLE analysis in this PUSH2HEAT project, and Paola presented already the main challenges and opportunities. Here I try to summarize again. It's a little bit repetition, and I will go on the several aspects in the next slides. So I try to visualize a little bit these, let's say, words, and this is my goal of today. So the first challenge is integration. Integration of high temperature heat pumps or industrial heat pumps. In my opinion, first we need a good energy analysis of the site. So the process engineers can do, for example, a pinch analysis. That's one of the most useful tools. And then there are questions to be answered. Is there a heat demand? Is there a cooling demand? What is the supply temperatures? What is the heat source? Is it sufficiently available? Is it the same order of magnitude like the heat demand? And also at the same time, and so on. Is there heat recovery potential? What is the operation profile? All these questions have to be answered. An analysis has to be done, and then maybe a heat pump, it would be a possible measure. So integration starts really with a good energy analysis. And then the second point, also from technical view, is that integration can be a complex task. So first we come up with an integration concept. So we find out, okay, this waste heat, it will be available as a source. We want to make steam. Here an example for a food manufacturer that needs low pressure steam for cooking some sausages, and they have chillers, ammonia chillers with waste heat 40 to 50 degrees. So an idea could be to integrate a high temperature heat pump in this process. Then the next step is to find possible heat pump suppliers and possible technologies. So we look at it as a black box. So it's a machine. This heat pump can provide heat and cold, and how it's designed. That's the knowledge of the heat pump manufacturers. And today there are several in this meeting. So think about that. And then the next step is the situation on site. Is there space available? And see here an example, a picture from a gas boiler which should be replaced, or let's say replaced by a steam generating heat pump. On the right you see a steam boiler, and then the heat pump space will be that space. So there are some constraints, and also the refrigerant. If you would go to a hydrocarbon, this would be maybe challenging as well. So there are complex situations which is very individual. So that's the message. And another topic is today's steam networks are typically generated by steam boilers. So they have high pressure, and then with expansion valves, we reduce the pressures to the different levels, which are then used, the different temperature levels or pressure levels, which are then used on site. And when we change to heat pump technology, then we have a mind shift. We have some other approach. We come up from the bottom, from the lower temperature. We are upgrading the waste heat with compression technology, which are mainly electrical driven with the compressors, and generate hot water, then low pressure steam, and so on. So it's a different approach how to, let's say, feed these steam networks. That makes the integration complex. Now about the technology readiness level for heat pumps, this can also be applied. So we have university lab units in small TRL level, then prototypes, and then industrial scale realization. So the technology gets more and more commercialized, and we need to scale up the heat pump technology. We need to standardize it and also have modularization. These are the major, I would say, let's say, goals for the technology development. We have here a table that shows several heat pump manufacturers and products. It's a selection, or it's not full picture, but to visualize it on one PowerPoint slide, we see on the right that these technologies get more and more to higher TRL level. So this is based off Annex 58, so status August 23, so almost 2 years ago. And there were several heat pump products available, commercial available. So the technology is there, it is here, but it needs to be used and integrated. So that's the major message here. And also standardization is important to get the economy of scale. An example is SPH, as I know Thor will follow with some presentation later on, but in PUSH2HEAT, SPH develops a heat pump, a steam generating heat pump for a paper factory in Felix Schoeller Group in Weissenborn. And what is, I think, a major competence of SPH is that they offer modular systems, so they can design their heat pumps to the customer needs. So, for example, on the condenser side, they have the possibility to have water or hot water, pressurized water, or steam. They have different types of heat exchangers and different configurations for this condenser side. On the evaporator side, also here, there are different media possible, water or steam, different temperature levels, and different configurations for the heat exchangers. The compressors can be multiple units or single units, can be parallel arrangement or in a two-stage cascade, for example, like shown here in this picture. And also the refrigerants, there are options to change to natural refrigerants or to keep the synthetic HFO refrigerants with the piston compressor technology that offers that. So modularization is important. And also another aspect is education. So we need to educate the engineers and the planners and the consultants and all functions, let's say, in this value chain. And here we can offer education course at our university. So it's a little bit of promotion, but I think it will be the case in many European countries that the universities or research centers start now education projects and education courses. So this one is available here from our university, also in English. In September, it will be in German, but then in English again, April, October. Education is important, and also research. So we can say, okay, heat pumps are available, they are commercial, why should we still continue with R&D? But we see many, let's say, R&D blocks. Here you see some demonstration of this technology, refrigerant optimization. Now we have projects that do refrigerant mixtures to optimize the COP depending on the temperature conditions on the industrial side. There are some soft science as well, or let's say business modeling and so on, techno-economic analysis. We want always to improve the COP of the heat pump, better compressors, better heat exchange, and so on. So there are several technical related R&D activities still ongoing and must to do. Now to the economic factors. So here we have the list from the PESTLE analysis from PUSH2HEAT project. We heard about it already. Costs and so on are important, business models and so on, and subsidy or European funding programs and so on. I want to visualize here again this economic aspects a little bit. So from market diffusion or market adoption, we know the S-curve. So there are some end users that are innovative and they invest into a new technology, these innovators. And I would say at the moment we are still in this early stage of this market. So what is needed is a more commitment to sustainability and decarbonization. We need economic incentives. We need to involve all the stakeholders in the value chain, have more awareness of technology and support. So in blue, there is the market share for residential heat pumps in building sector in Switzerland. So you see in the residential area, the heat pumps have already passed the majority. So this is like standard technology, let's say. And in industry, we are just about at the beginning. One factor is the CO2 levy or the CO2 tax. In Switzerland, I can talk about that. It's increased to 120 Swiss franc per ton of CO2. And this is a driver or a steering parameter to push towards more decarbonization. And I think that is one of the, let's say, successful and accepted measures also for industry. When they have very large industrial heat demands, then they have some exceptions, but in principle, this is a possible measure. The electricity is important, so the costs, if it's lower price, then heat pumps have more chance and they sell more. And this we can see here, for example, from the study of the European Heat Pump Association for households. So this is not industry, but you see if the electricity to gas price ratio in the x-axis goes down, so from right to left, then there are more heat pumps sold. There is a correlation, I think, with Sweden here, 35 heat pumps sold per 1,000 households. When you go to industrial size, or let's say there is not much data available, but for district heating, there is some data as well available here from a study in Germany. So also here we see that there are more large-scale heat pumps in district heating when the electricity to gas price ratio is lower. So here it seems around 2.5 or somewhere there, it starts to get higher share. Okay, this price ratio is depending on the country and especially also on the location where the industrial site is situated. So very local contracts from the companies with the energy suppliers, with gas and electricity contracts. So we can have another view and translate this, let's say, price ratio to application. So what does it mean if the price ratio is lower? Then we have an economic COP that can be lower as well. And and this is in principle, we have a higher temperature lift that is still economical. And then when we have a higher temperature lift, we have more applications that can be have the potential for heat pumps. So there are some applications which have quite high temperature lifts from heat source to heat sink, and the COP of the heat pump will be lower than in other situations. But if the price ratio is also in a meaningful range, then these applications have also potential for the heat pumps. The investment cost, that's a very important factor. But the message is that the heat pump is not the only equipment in such a project. Maybe it's maybe 50% of the project cost, but a substantial part, that's for sure. But there are other costs like connecting the heat sources, the heat sinks, construction, electrical connection, planning, and so on. And a message is that there is an economy of scale. So this we would expect as well. So if the heat pump manufacturers can design their systems and increase the capacity with larger compressor, for example, the specific costs of the heat pump in principle should reduce with higher size. But it still is still an early market, so it's always important to get real offers from the heat pump suppliers to do the proper techno-economic analysis. We did some interviews with heat pump manufacturers, and what business model is the most, let's say, used one? It's the purchase. So it means the end users want to buy the heat pump and own the heat pump, and then they want to have service maintenance contracts from the heat pump supplier. So this is the typical approach, but we see also newer business models like heat as a service and so on, that is more customer oriented, and the customer is more integrated so that they would buy the heat and somehow lease the heat pump. So there are some opportunities for business modeling and so on. Another aspect is alternative technologies. So the heat pumps are in competition with biomass and also with other technologies, biogas and electrical boilers, direct electrical heating with a COP of 1 or a little bit lower. So possible substitution technologies are relevant. So to finalize, here another slide from a survey about the barriers, economic barriers. So in summary, we have knowledge and information barriers. So then we have the cost situation, which is very influenced by the boundary conditions. We can, by the situation where this production site is and the costs. And we have the technology. So now these higher temperature industrial heat pumps are more and more further developed and also more available at high temperatures. So summary, 3 key messages or recommendations from, let's say, our side or my side to bring this heat pump technology more into the market. Better knowledge transfer. So we want to inform the consultants that there is this technology available. There are more and more demonstration references available, and also more applications are realized. Then a higher level of standardization to reduce the costs of this technology, and then guidelines and qualified people that are able to do this integration. So that's from my side as an input or perspectives on this technical and economic factors of the PESTLE analysis.
Thank you so much, Cording, for your okay. Thank you. Thank you, Cording, for your insightful presentation. I need to reshare the presentation straight away for the next speaker. But in the meantime, if you have any question, please don't hesitate to write them in the chat by mentioning the related speaker. So if you already have some questions for Josephine and for Cording, please go ahead. The speakers can answer straight away in the chat, and then we can address them in the panel discussion. Just a few seconds to reload the master presentation. And then we will have our next speaker, that is Milan. Okay, so let me introduce you to Milan Perez-Caman. She's a project manager and energy researcher at the Cardiff Technology Center. Her research actually supports the development of heat upgrade technologies and innovative solutions that improve energy performance and sustainability in both industrial and building environments. She's currently pursuing a PhD in engineering, and today she's a project manager and energy researcher at Cardiff. So Milan, whenever you're ready, you can take control of the presentation and start presenting your slides.
Thank you, Paola. Okay, I think I have the control now. Okay, as you mentioned, this is a reflection from the field of the future of the heat upgrade technologies, and this is an academic perspective. First, I see there is a 22% of research universities are police organization. For this reason, I think the best is start with the highlight the work of these sectors. The universities and research centers, they are not only developing technology for waste heat recovery, they are also helping to create the condition for this technology to be adopted in a realistic and efficient and sustainability way. And some of the strong point is the knowledge generation and translation. University not only produce knowledge, they also translate it into practical tool, guideline, and methodology that help industry implement energy solution with confidence. Also, a strong point is the reducing uncertainty through data and validation. Research centers play a key role, reducing the perceived risk associated with the new technology and provide evidence through simulation, field validation, and the performance monitoring. Another point is the neutral space between the stakeholder. The academic institution often add a break between the industrial need, policy framework, and societal expectation, supporting balanced decision making based on technical evidence. For the last point is the system-led thinking. We have shifted the focus from isolate technologies to integrate system-led solution, considering how we heat recovery interact with the energy demand and renewable storage and police. Sorry. Okay. To continue, many of the barriers it's highlighted in the survey are known at this point of the presentation, but some deserve special attention, either because they are special critical for a technical point of view, or also because we see them repeatedly in the real world projects. In this, we'll make a selection. For this, on the economic point, will high upfront cost is a common concern. I believe the real underlying issue is the lack of tailored business model. As research, we often see promising technology extrude not because they don't perform well, but because they don't fit existing investment structure on operation instead. Should better participants identify this clearly, and I strongly agree with this part. Without flexibility, a chance such as a hit a server or shared saving model, even cost-effective solution may remain only on paper. For the technical part, this was one of the most frequently mentioned technical barrier on the survey, and I completely agree with this part also. Integration, it is not just about the temperature level, it's more than that. It's about control system, spatial control, production schedule, and safety procedures. In several demonstration projects we have worked on, we learned that integration must be considered from the day one, not left as the final only before submission. For the legal part, this is a subtle but very powerful barrier. In many national European framework, waste heat is not clearly recognized as a valuable energy source. As research, I don't see qualify for a planning priority, funding scheme, or long-term energy strategy. This where academic can help by building the evidence and reforming waste heat as a critical asset for the decarbonization. On the social part, sometimes the real barrier in this part is not a technical one, it's more a cultural one. Waste heat is still seen by many as a nuisance, not a result itself. There is a clear lack of technical training in the area, and often a disconnection between what the technology can deliver and how they are perceived. And here also the university and research setting can play a major role here by providing training, informing police, and changing the narrative through the communication and evidence. For us, it's important to say the barriers don't exist in isolate, they reinforce each other, and the role of the research, it is not only to invent solutions, but to connect them with the real world and the constraint and opportunity. We must act not only as innovator, but as a connection too. Okay, the next slide is about more the opportunities. With the barrier real and complex, the opportunity hand are used as target, and includes this is perhaps over more exciting when viewed from the field. On the police and the financial beyond side, there is clear need to explore financial models that are more flexibility and better aligned with the industrial decision-making process, whether through leasing, shared saving arrangement, or saving-based model. To goal should be the reduce upfront risk and make investment more accessible, particularly for the small and the medium-sized companies. And from our perspective, this model works best when they are developed in parallel with the technical solution, not as an afterthought. On the technical part, this is a real game changer. Loss of standardization is one of the big obstacles to scaling up the heat-to-grade temperature technology. If we can ensure common interface, communication protocol, and module design, we move from a tailor-made system to a scalable solution. In applied research, we should push for open standards and compatibility from the early stage of development. And on the sustainability, waste heat recovery become one of the most powerful way integrated with the renewable energy and district heating, for example. And this energy allows us to store, distribute, and use the thermal energy in a more efficient and coordinated way. From the academic perspective, the challenge is to model this interaction and demonstrate the technical and the economic value also. Our collaboration, this is of the most promising trend. We have seen the growing collaboration between the research, the industry, and policymakers. The partnership crucial to align technology developed with the market need and with the regulation framework. We must move from isolate pilot project to co-design solution where industry is not only just a test site, but the true partner in the involving in the solution. Well, it's important to highlight all these opportunities to one thing. We must think on a system. Technology innovation is not enough unless it's fit into broad energy regulation and business ecosystem. Our role as research is to make sure the solutions we propose are not only innovative, but usable, scalable, and aligned with real needs. At research, we often focus on developing and testing new solutions, but for this technology to be truly adopted, our work needs to go beyond that lab. Applied research play a vital role in industry uncertainty by validating technology in real environmental and by generating data that support decision making. For example, in a project like the PUSH2HEAT, we have see how this type of research helps connect innovation with operational reality and improve the dialogue between the developer, the user, and the policymakers. At the same time, we have noted that limit technical knowledge or where we slow down implementation, even when the technology itself is ready. That's why target training and broad communication are essential. It is not just about knowing how the system works, but understand their value in a broad energy strategy. Academic institution, we have the opportunity and also we can say have the responsibility to support the process by developing a skill and furthering a more informal culture around the energy use. This is all for my side. Thank you.
Thank you, Milan, for your presentation. And again, if you have any question for Milan, please write them in the chat. We can move on now and switch more from a perspective from the industry. And we can go forward with the next presentation that will be delivered by Tor Hodne. Tor has a business background and works at SPH, Sustainable Process Heat, a company at the forefront of industrial heat pump technology. He has spent his entire career working with innovation and startup, and for the past 15 years, he has focused on the green tech sector, and he's now Chief Commercial Office at SPH. So Tor, whenever you're ready, you can take control of the presentation and go ahead.
Thank you very much, Paola. Let me see here. Yeah, so I'm very happy to join the roundtable and share a manufacturer's perspective on the future of industrial heat pumps. But let me just start with a quick introduction to who we are at SPH, what we do, and why we are part of this PUSH2HEAT project. But before we even go there, this is a picture of one of our heat pumps. It has been built. It is real hardware. It works, and you can buy it. As mentioned by Corden earlier, our therm booster heat pump is a very flexible technology which can run on a large variety of heat sources, anything from cooling water and process waste heat to solar and district heating. And on the heat sink side, we can provide hot water or thermal oil or saturated steam directly all the way up to 160, 170 degrees C. But who are we? Let me switch to the next slide here. SPH is a dedicated industrial heat pump company which was founded back in 2020, and we focus entirely on decarbonizing process heat. So after securing the first round of investments, building our first compressors and setting up our test facility, we joined PUSH2HEAT because we believe that by working together with researchers, policymakers, and the industry, we can identify and overcome the barriers to large-scale deployment of heat upgrade technologies such as ours. In the PUSH2HEAT project, we are delivering a two-stage heat pump utilizing a waste heat source of around 45 degrees and producing steam at around 2.2 bar for the paper drying process at Felix Schoeller in Germany. The hardware and the installation in this project is of course very important, but through the project we are also developing business models and so-called exploitation roadmaps to help push more high temperature heat pumps into the market. So in short, we want to accelerate decarbonization of industrial heat, and we know we cannot do that alone. So today I'll share some of our real-world reflections on the PESTLE analysis from the project, including the key barriers, the growing opportunities, and what we see happening on the ground. So let's start with the barriers. First, the economic barrier. As mentioned before, high capex is perhaps the single most common challenge that we face. And even with favorable ROIs, we experience that many industrial customers are still hesitant. They may not have the cash on hand, and many companies are extremely risk averse when it comes to production critical equipment. So they might just stick with their inefficient gas boiler that they know, rather than invest in new technology with a higher upfront price. Adding to that, many prefer to be followers and not first movers. They view it as risky, especially because very high temperature heat pumps are running in the field so far. So from our point of view, many more large multinationals with big pockets need to step up and lead the way, even though it may be risky. The public subsidy processes are often very complex as well, and few of our customers have actually made the effort to even obtain these. Innovative financing models like leasing and heat as a service could help, since they take the investment off the balance sheet. However, the most important thing, the way we see it, is to get more systems running successfully in the field, and then it becomes much easier to justify the investment, even with a high upfront capex. Technically, installing a high temperature heat pump is more complex than replacing a gas boiler. Whereas a boiler is largely plug and play, heat pumps often require a source of waste heat, or they always require a source of waste heat or heat sink integration, which must be engineered case by case. Heat pumps do need a heat source, and sometimes that source isn't available, or it's at a very low temperature, which results in high temperature lifts and thereby also lower COPs. We also face integration challenges, so retrofitting a heat pump into an older facility can mean dealing with lower temperature waste streams, space constraints, or process adjustments. These processes are time-consuming and complex, and for the time being, it's also challenging to find experienced engineers in this field. Right, moving on. On the legal side, we haven't really faced many obstacles yet. However, as mentioned earlier in this session, refrigerants remain a concern. There's uncertainty still around refrigeration policies. For example, EU F-gas regulations are becoming stricter. In our heat pumps, we use mostly HFO refrigerants with a very low global warming potential. However, we must keep an eye on regulatory acceptance and any future environmental findings about these. Fortunately, as mentioned by Gordon earlier, our heat pumps can also run on natural refrigerants like hydrocarbons, but these are flammable and toxic, and we then run into safety codes which need to be tackled. So for us, there's a bit of a catch-22, HFOs versus HCs. Each has pros and cons, and we hope that legal uncertainty can be overcome in the near future so that we can also have a clear long-term framework to work within. On the social side, the good news is that awareness is certainly growing. At SPH, we now receive, say, 5 to 10 new inquiries per week, even without much marketing, so the leads are many. However, technology trust is still generally lacking from many of the customers, and many of them still ask questions like, will this system really last for 10 years? How many units do you have running in the field? Can you show me where this has been done before and in a plant like mine? And if we don't have a long track record to point to, it becomes a leap of faith for these early adopters. And this lack of long-term references is indeed a real hurdle. So more systems in the field will certainly build trust and reduce this barrier over time. Okay, so let's turn to opportunities. And these basically fall into 4 main categories. Policy, technology, ESG drivers, and collaboration. First, policy. Public support is certainly increasing, and we see more incentives, better funding schemes, and clearer mandates. We also see that the application processes are becoming easier and shorter in many places. And countries like Austria and the Netherlands are already making real progress, and we hope that other countries will follow. Second, technical maturity. Systems like ours now reliably deliver steam at over 150 degrees C with COPs above 2.5. R&D, standardization, and real installations are improving performance and integration processes. And we know that a relatively large number of heat pumps are being deployed in the market this year. Third, ESG. Sustainability is now becoming a real business driver, actually. We see that the push for heat pump adoption often comes from the ESG or sustainability teams, and not from operation. This is certainly because of the company's brand, compliance, and investor expectations, but in many cases we also hear that it's in fact also consumer driven, which is interesting. And fourth, collaboration. PUSH2HEAT and similar platforms help build trust, create shared knowledge, and demonstrate real-world viability. And this is essential to scaling up deployment and faster market adoption. And then last but not least, sales are indeed picking up, and more units are coming online, both from us and from other companies. There is interest from food, pharma, and the chemical industries. It's growing rapidly. And other industries also show concrete and eager interest. Now, for us at SPH, we will have 10-12 units running in the field within the next 12 months. They are both hot water and steam units. There are 1-stage and 2-stage units in a large variety of temperatures and industries. And this will hopefully make a big difference when it comes to trust, both for us and for the rest of the heat pump suppliers out there. So final words, at SPH, we are committed to pushing the limits of what's possible. And we are very optimistic about seeing strong growth in this market in the coming years. That's it from me. Thank you very much for your time.
Thank you so much, Thor, for your presentation. We can move on now from another point of view, also from the industry perspective. Let me introduce you to Bart Ertz. Bart holds a bachelor and a master degree in electromechanics from the Limburg Catholic University College. In 2003, he began working as a production engineer at the Tienser Suikerraffinaderij, where he has been serving as a production manager since 2010. He's now the reference person on behalf of the Tienser Sugar Factory for the SPIRIT project, overseeing, of course, the integration of industrial heat pump at the demonstration site in Tienen. So Bart, whenever you're ready, you can take control of the presentation and go ahead.
Hello, good afternoon, everyone. Or no, not noon yet, but hello. Thanks for the introduction. We have a high temperature heat pump at our site, and we're also inside the SPIRIT project. And the main reason why we have this heat pump is, this should look like an ideal sugar production, that we can just only harvest sugar beets and directly get the sugar out of it. But unfortunately, a sugar beet contains a lot of water, which we have to evaporate in our installations, and that's why we have we need a lot of heat. And this heat today is produced by steam or is transferred by steam, and also with conventional boilers. We are part of the Zoetsucker group. So Zoetsucker group is a group which produce sugars, but also other things. And we also complied with the targets, the scientifically based targets for 2020, 2030 and 50. And this is also why we looked for some technologies which are for us interesting. Before a lot of years, we focused a lot on the maximum reuse of energy, because energy is expensive. So we spend already a lot of budgets and investigations, engineering on the reuse of energy, the reuse of condensate, things like this. And the new technologies for us are to see, okay, can we also process biogas, because we do have some material on site. And another step is then electrification. In this electrification, the heat pump concept pops up, and then we had the opportunity to enter the SPIRIT project, and then we made a concept that we would install, and we have done it, a heat pump of 4 megawatt thermically, and which is working with pentane. And our heat source is vacuum steam of 80 degrees, which we transfer then with the heat pump until a temperature of 140 degrees approximately. The working of the heat pump you all know, so I will skip this slide very easy, but as you can see, we will take approximately 3 megawatts of heat, and we have an electrical motor of 1 megawatt, which we transfer then into the total capacity. This is a glimpse of our production process. As I told, we have a lot of water to evaporate out of our sugar juices, which is done today in falling film evaporators in a multiple effect like this. This type of installation you will see in all types of sugar processes. Today, the left side, we are using this steam coming out of our boiler, but the steam is reused in different evaporators until we have used approximately all of the energy, and a part of it, because some of this steam also exists of non-condensable gases, has to go to a condenser. This is a small loss which we still have today, and there the idea started to have it better, and then we will take back the energy and we will transfer it with the heat pump to a higher level. And in this case, we can also see that we will reduce the amount of steam coming out of our steam boiler. This is done. This is what we did, and now the installation is built. For sure, we will also feed this heat pump with electricity, and there also for us the question is, how green is the energy which we purchased? Because there in Belgium, for example, we have some nice possibilities to buy a share of a windmill which is built in the North Sea, but not all countries have these possibilities. Here you have a view on the 3D model of the heat pump. As discussed already, the heat pump is only a part of the full installation, and it's also a part of the capex. So we installed the heat pump outside of our production building because we have no experience with pentane, we had no experience with the heat pump, so we installed it in a new building, which is quite expensive. And also, as we have vacuum steam, we had to place the heaters on a height, because otherwise we would have issues with condensate which will not get out of our heaters. So the heaters, the sink and the source heaters are placed on the top side of this building. This is how it really looks like. So we have done the project together with GEA, and at the right side you see the motor of 1.3 megawatts, and behind there is a screw compressor. At the left side you can see here also some oil heat exchangers, and this is all installed in a area which is then flame tight or burning resistant for 1 hour. It's also an ATEX environment, because we had still some long discussions concerning what in case of a leak of pentane. And then we try to keep it as safe as possible for our operators, which are not so experienced in working with heat pumps, because it's not our core business, and that's why we also foresee the full room in an ATEX environment. This is a top view, drone view from the heaters. Another aspect is the heaters, they are working with a quite small delta T, so the installation for a 4 megawatt heat pump is quite big, and this is also by the fact that we also have steam with some other components in, and therefore we use gel in tube heat exchangers, which are a little bit bigger than standard plate heat exchangers. This is a side view from the installation. You can also see in this area we have a transformator, we have a E-room for the electrical components, for the frequency converter, things like that. But at the end it's a quite big building with all this equipment on, and to be honest, it's also more expensive than we had foreseen in the first budgetings. What are some challenges? For our business, for sugar production plants, by using pentane as a cooling fluid, for example, you add an amount of burning gas into your plant, and this has an impact on ATEX, on higher cost, but it's also a non-food product, so we should take care, in the food business, that our products are not in risk by using these fluids, which is not the case, but it's an additional point to have a look at. We have a high energy demand, so as well thermal as electrical, so we need investment. As I already explained, we had to invest a lot in the building, in the installation, and we do have also a CHP installation, so with less steam production, we also have a little bit less electricity production, so we have to purchase more electricity on the grid, and there also the price setting of this electricity is very important for us. The heating applications in RD is in plant to plant not always the same, so standardization is quite difficult, and it will be not so easy to make a standardized pump, so it will be more tailor-made. An additional point we also had to build was a full ventilation, one for the cooling of the area, and two for in case of leaks. So we have a propulsion group and extraction group which is always on, even if the heat pump is out of service or in maintenance, And yeah, as pentane is heavier than air, we have some detectors at the bottom, and in case of a leak, we go up in a higher extraction amount that we take out of the area in order to stay always in a safe level, in a safe LAL level, that we don't exceed a kind of explosion environment. So this is also a full installation which is needed in our installation. Another point we took on with the fire brigade and also some safety engineers was, in case of a leak, we also with oil which can enter our sewage system. One, this is not allowed, and secondly, it's very dangerous because then your full sewage system can contain pentane, and that's also why we connected our sewage system to a separate tank of 20,000 liters, and in case of an alarm, all the water which is in the or in the building will go to this tank. What are the most important learnings for us in this project? The electricity price will strongly influence or facilitate heat pump projects, but this is already mentioned. The heat exchangers are challenging due to the fact that there is a low delta T, and this will be difficult to standardize. You need for sure a good electricity connection, and a lot of facilities, even in our group, will need new grid connections, which is in some areas really difficult. Costs, as already told, capex was higher than foreseen. Due to this project, we also learned that there are really good applications for heat pumps, but you should always have a look, okay, what is my heat source, and find the right the right machine or the right project for your solution. And we have to see that all this cost has to be paid by our customer at the end, and he or she doesn't want to pay too much, so that's why we try also to keep this cost under control. This was it from my side.
Thank you so much, Bart, for your presentation, and thanks also to all the speakers. You all clearly set the stage for a deeper understanding of the current landscape around heat pumps. So now, before moving forward to our next session, I just want to take a little bit of your time to answer some polls that you can see popping up in your screen right now. So in order to broaden our findings and the perspective on these issues, can you just answer to this question? So in your opinion, what is the first technical barrier preventing a stronger uptake of heat pumps in the industry? Of course, you can answer by referring to what you've just heard, or based, of course, on your field of experience. So let's see some results. Okay. Situation is changing every second. We have, for the moment, a majority of people voting for a limited awareness or understanding of the benefit. There is fighting with the lack of standardization and interoperability among different technology and energy networks. Okay, thank you so much. We can move on to our next question. So yes, in your opinion, what is the first non-technical challenge preventing a stronger uptake of heat pumps in the industry? Let's see which results we will have on this one. Okay, definitely the electricity to gas price ratio, it's at the above of our ranking. Let's wait for another few seconds. And yes, I think our okay, so I think the electricity to gas price ratio is one of the first non-technical challenge that the impact world is facing right now. So we can move forward to the other session of this webinar, and I'm going to introduce you to our panel discussion that will be moderated by Josephine Van Besseler from EHPA. So yes, please, Josephine, whenever you're ready, you can take control and move forward to our next session.
Thank you very much, Paola. This was also from my side a very interesting webinar. As you heard, I work on the policy landscape for industrial heat pumps every day. So it's really also nice to hear from people actually implementing and the technical people on the ground, also their insights. I actually, as a first question, wanted to come back to the last poll question that was raised on the barriers and mainly the CapEx versus OpEx, because I was on Tuesday at the conference in Munich, and there we had a roundtable also on industrial heat pumps, and there was really, this was also a question, what is the main barrier? And people were really divided in the room, like, is it CapEx or OpEx? And also here I have to say, from the different speakers, I hear a bit of a mixed feedback. So I had the feeling from Cordin's presentation, he referred mainly to the OpEx, so the electricity to gas price ratio. Then Thor was more focusing on the CapEx, and also from Bart, I really hear both. So I would like to just maybe bluntly ask you, okay, we heard from the public, so from the people here in the webinar, that I think it was 53% OpEx, 39% CapEx, so it's quite close. But how do you see this? Like, what is for you the absolute main barrier? Is it CapEx or is it OpEx, or even what is the easiest one maybe to solve from your perspective? I don't know, who of you would like to go first? Otherwise, I'll put someone on the spot.
Yeah, maybe I can say a word on this. I think the electricity price is the main driver. If the electricity price will drop down, yeah, then your business case and ROE calculation will also be better, and it will be much easier to convince your direction board or board of direction members to invest in this new technology. So, and then the CapEx is a secondary aspect.
Thank you, Bart. Do the others agree with that? Cordin, maybe?
Yes. I think the OpEx defines the COP, or let's say the application. A certain COP is somehow economic, and this is very much depending on the operating conditions and not so much on the CapEx. I think when the companies invest into a technology, they know they have to spend some money for this investment, and at the end it's more the reliability that this machine or this heating system has no problems in this lifetime, no big maintenance. Let's say it should produce steam all the time when needed. So this is, I think, much more important than all this economic thing as well. But so we see also the projects that are realized are in countries where the electricity to gas price is low. So this has some correlation.
Okay, thank you. Very clear.
Yeah, I kind of agree to that as well. So from a general point of view, the gas to electricity price ratio is extremely important for customers to even consider heat pumps. But once you get into this, the direct discussions with each customer one-to-one regarding a particular project, then the CapEx is also often a very high barrier.
Okay.
Hi. I want to add also, it's a personal decision, of course, how everyone said this. Every client of every building or industry is totally different. But I see there is on the market, there is normal today have a on-situ generation, and maybe this electricity is free, and maybe then it is not a problem. It's a good opportunity to use that energy is free, and maybe when your demand is not so high on the electricity, you can use it. I see this more on the building sector, maybe for climatize or something like that. But I suppose many industries also had a generation system for electrical on city.
Okay, thank you. I maybe want to connect this to a question in the chat. So we have Aurélie Grélo who mentioned, did you compare the electrical boiler to the heat pump solution? Electrical boilers are in some way cheaper but less efficient. That is then, of course, the capex that is referred to. Any comments on that? We hear sometimes maybe clients opting for electrical boilers rather than heat pumps, or how is the issue there?
Yeah, from my perspective, that has really a lot to do with the COP. So if you have projects where you have high COPs, then it's much easier to go for a heat pump. But if the COP is low, then they might go for the electrical boiler instead.
Thank you.
Yes, I can add. So the heat pump is not for every application. So if the temperature lift is higher than, I don't know, 120 degrees, then the COP goes towards 1, and then there is no benefit for a heat pump anymore. So you have to find a suitable application. And a second point is the base load by a heat pump at high COP would be a good solution. And then the peaks maybe with an electrical boiler, which can be a small one. So a combined electrification system with a heat pump and an electrical boiler could also be a solution. So it's not only one by one.
Okay. Anyone else wants to comment on this? No? Okay, then let's go to a next question. It's a question also in the Q&A from Hélène Rivière-Calu. I see that Thor already answered, but I want to broaden it a little bit. So she's mentioning one of the barriers I see here is that actually new natural gas boilers can actually be quite efficient. So the business case is complicated to scrap a perfectly running system, sometimes still in amortization periods. Any insights on this? How to go step by step towards hybrid solutions and start with multi-fuels? Maybe also adding from my perspective also, I heard from paper and pulp industry, for example, that for them it's often a big barrier also that they have to stop the current process to rebuild the process to adapt to to integrate heat pumps. So I think this could be linked as well. Is there a way to stepwise go from one system to the other that would make it maybe that would lower the barrier somehow? Any visions on that?
I guess that would be quite site specific. In some of the cases that we are looking at, they are able to run whatever they have at the moment in parallel with us installing the heat pump, and then that transition is easy or easier. In other cases, there is perhaps not enough space for both, and then you have to really just do the switch.
Okay, very interesting.
Which of course is more risky.
Mm-hmm.
A stepwise procedure could also be to electrify stepwise. So have the gas boilers still in place, but reducing their duty towards the electrical driven technologies. And then there are situations where backup is needed, or some situations where the heat pump maybe is in maintenance and so on. So it's not a full replacement of a gas boiler. That should, I think, from my experience, companies have several heating systems to produce their heat in parallel.
Okay, thank you. Maybe Bart, how did you approach this?
Yeah, I think in the next years, companies like ours, we will have a look at the flexibility, because today you can have really good electricity prices on the spot market, which is then very interesting for electrical production of heat. But yeah, it can also be another case, and gas will become more cheaper in some circumstances. So we will go for both technologies in parallel, and also to check the reliability, because today we have poor experience with the reliability of the heat pumps, for example, and this will be also then one of the factors for the future.
Okay, thank you. Okay, then I will go to another question. So we've heard from these new business models, this heating as a service, but from what I hear, it's mainly currently still mostly theoretical. Do you see this popping up already a lot? How common is this? Is this so? Yeah, how can you give your vision on these new business models and how you see them currently in the market? And
so I bring this up in a slide from a survey with different end users and heat pump manufacturers. So heat as a service is more used in residential heat pumps and also maybe district heating heat pumps. And so it can be an option for the future. So especially in larger, for industry, especially in larger industrial parks, where there are several companies where the heat is somehow like an energy like a utility produced in a central point, but then delivered to several end users. And so they do not need to invest into single heat generation systems, but can arrange some kind of a contract for buying the heat or the cold. So in these larger industrial parks, this could be a business model. For the smaller companies, like a meat manufacturer or something, or a milk producer, they want to own their heat pumps, so their heating and cooling systems. Yeah, it's a market that will be maybe in the future more with this heat as a service, more in the future, an opportunity.
okay, thank you. Any of the others have experience with heating as a service or heat pumps as a service? No.
We've had a couple of cases where we have looked into this, but it becomes very complicated. And I agree with Gordon that there will be some more special cases where this is more relevant, but at least for now and the foreseeable future is probably not going to take off very soon.
Okay, oh, that's very interesting. Okay, good. Thank you. So let's see. I think there's in the meantime no additional questions in the yes, we have one here on flexibility. So question, do you have insights on improving the business case with revenue stream from grid flexibility solutions, meaning having heat pumps plus storage and benefits from peak shaving and ancillary services? I think Bart already really responded to that point, that you will be looking into this in the future, and the combination also with gas and using electricity when it's most beneficial. Anyone else wants to come back on this point on flexibility, how you look at it? If your heat pumps, I mean, yeah, that you are, do you see already on industrial sites really heat pumps used in a flexible way at the moment? I think maybe in combination with district heating, maybe, but in industry, anyone? No.
Yeah, so for sure. Yeah, I think it's a question also on the scale. So if there is a very large heat pump, so in the 10 megawatt and so on scale, which is more often in district heating applications, and in locations or in countries where the electricity price can be almost negative at certain times of the day. This will be very, very important. So as a, yeah, I think it's a business case that is considered, and in the next years, this will not change, I think, so much. So that's especially in countries where the renewable electricity is certain hours of the day almost for free. And then you can run the heat pump with almost free electricity and generate hot water, for example, in a storage tank, and then use the hot water at times where it's needed.
Probably this will also depend on the industry,
on the size,
and whether they are how do you say, it's possible to be used in a more flexible way, or they have to run very stable 24/7 or something. That could probably be a factor as well. Milen, you switched on your camera. I don't know if you want to come in on this or
Not good. Okay, I can share more or less my opinion on this. And I think I see another project and another case. They used to the heat pump with a storage, or to have the storage, of course. With then when the conditions are best, and it stores this energy and use after on the system you really need. And I think this is great application.
Thank you. We're almost at the end, so I'm just checking. There was an additional question popping up. I saw a question for Bertie. I don't know if that will be possible, but someone is asking if he would be able to share the capex for the different parts of the heat pump implementation. I don't know if that is possible, maybe too detailed. Let's see, but if we can share.
It's not so easy because we have different budget used, so it's not so easy. But I think we can say that I think the cost from our side and it's if we have to purchase this heat pump, I think we are it's a kind of rule I have in my mind is that you're speaking about 1 million per megawatt hour, something like this.
Thank you very much. Okay, then I think this was a very interesting panel discussion and also a very interesting webinar as a whole.
Thank you. Thank you so much, Josephine, for moderating this panel discussion. I think all the inputs were really valuable to broaden this discussion. Before closing up the event, I just wanted to few reminders about following these two projects on our website, on the LinkedIn page. You can also subscribe to our newsletter in order to be updated on all the results and the publication. They are going to be available soon. And then, of course, if you want to join more events like this, or you want to be part of the heat pump world, follow EHPA on our social media. And you can also check different materials available on our website. So please stay connected. And yes, thank to all of the participants and of course to all the speakers for joining the webinar. Your contribution were really valuable, and it helped us a lot to broaden our vision on the barriers and the opportunities for the heat pump world. So thank you everyone, and I hope to see you in our next event.